we're going to start topical past paper questions of physical quantities and measurement technique. Starting with the first question, five identical spheres are placed between two blocks in order to measure their diameter. What is the diameter of a single sphere? Okay, so as they are identical, so first diameter is this. This is also diameter of a sphere. The third one, fourth, and fifth. And we know that for these five diameter, that is in total it's starting from 5 and it is ending at 16. This point is 16 basically. This is 5, so 5 to 16, that will give you 16 minus 5, that is 11. So 11 centimeter is equals to 5 diameters. So 1 diameter is equals to 11 divided by 5, that will give you 2.2 centimeter. Okay, it's option A. Second question, a student wants to take a particularly accurate measurement of a volume of a liquid in a cylinder. Which of the following procedure would make her measurement less accurate? Okay, that is a option C. Using the largest measuring cylinder she could find. Okay, when you take a large volume, there will be a very small change when you add something into the liquid. Okay, so that will make your measurement less accurate. In question third, a student is timing the rate of cooling of a beaker of water, and on a repeat run of the investigation, the student forget to zero the stopwatch. The reading on the stopwatch at the time and the end of the time is shown in the figure. We have to calculate the time period. Okay, so it's starting from 11 minute and it is 19 second, and it is ending at 23 minutes and 27 second. So we have to answer in minutes and second. Okay, so we have to subtract minutes from the minutes, they will be subtracted, and seconds from the seconds. Okay, so 23 minus 11, that will give us 12 minutes, and 927 minus 19 give us 8 seconds. So it will be 12 minutes 8 seconds. It's option D. Question third, identify the physical quantity that is not scalar. Okay, weight is not scalar. Weight is a vector quantity. Speed, time, and energy are scalar quantities. Identify the physical quantity that is scalar. Okay, so scalar quantity is only distance. Weight, velocity, and acceleration are vector quantities. Okay, so question 1a, some student observe a drops of water falling from a tap that leaks. The student measure the time for the 50 drops to fall. The time for the 50 drops is 20 seconds, but we have to calculate the average time between the two drops. So simply to find the average time between the two drops, we have basically time for 50 drops is equals to 20 seconds. So time between two drops will be 50, it will be 20 divided by 50, that will give you 0.4 second. Okay, question 1b, a student collects some drops of water. The student measure the volume of the water they collect. State the term for the equipment that is suitable for measuring the volume accurately. Okay, so volume of a liquid is measured by measuring cylinder. Okay, and in a similar experiment, another student collect 0.21 kg of water. Calculate the weight of the water. Okay, you have to find the weight. So weight is equals to mass time gravitational field strength. Okay, as we know, gravitational field strength is constant and mass is given, so mass is 0.21 and gravitational field strength is 9.81. That will give you 2.1. So it will be 2.1 and units are already given. Question number 2a. 4 students P, Q, R and S each attempt to measure the time period. What we have to do, we have to find a state the student who has chosen the correct movement for one time period of the pendulum. Achha, one time period mean the one complete oscillation. So one complete oscillation is representing a complete path. If you consider it a circular path, then it will be like this. If you consider it a zigzag path, then it will be from this point. Let's suppose this is A to B, and then again from A B to this point. Okay, this is one oscillation. So if you look at the option S, it's going that way, then coming back, and then coming back again. So it's a complete oscillation. So it's option S. Question 2b. Another student uses a stopwatch to measure the time taken for 50 periods of pendulum. Shows the time taken on the stopwatch. Calculate the time period for one oscillation. We have given is for the 50, we have to find one, and you have to answer in 3 significant figures. So what we have to do, time is basically 1 minute 23.37 seconds. This is for the 50 oscillations. Okay, so for 50 oscillation is for 50 oscillation, that is 1 minute 23.37 second. So we have to answer in seconds, so we have to convert this minute. We know that in 1 minute is equals to 60 seconds. So this thing, 1 minute 23.37 seconds are equals to 60 seconds plus 23.37 seconds. This will give you 83.37 seconds. This is for the 50 oscillation. So for one oscillation, what we have to do, we have to divide 83.37 seconds divided by 50. So that will give us 1.67 seconds. So 1.67 is the right answer. Question 2c. The student measured the displacement of pendulum bob from its rest position. The displacement is 16.5 centimeter. You have to convert it into millimeters. Okay, so 1 centimeter is equals to 10 millimeters. Okay, so converting 16.5 centimeter, what we have to do, we have to multiply it with 10. That will give you an answer in millimeters. So it is 165 millimeters. Question 3a. A student measures the length of the side of a metal cuboid using a 30 centimeter ruler, and state the measured length of the following. Okay, if you see for the A, it's starting exactly from 0 and ending between 7 and 8. It will be 7.5. It is 7.5, or yes, it's 7.4 exactly. 7.4. 7.4 or 7.5, both are acceptable. Okay, it's 7.4 centimeter. And for B is also starting exactly from 0 and it is at 4. So it is 4 centimeter. For C, it is also starting exactly from 0 and ending at 12 or slightly before it. So you can write it 1.9 or 2, both are acceptable. Okay, so it's 1.9 centimeter. In the next part, you have to find the volume. Okay, so A side was 7.4 centimeter, B side was 4.0 centimeter, and C side was 1.9 centimeter. Okay, but volume we have to write down in meters, so we have to convert these centimeters into meters first. 7.4 divided by 100, that will give you an answer in meters, that will be 0.074 meters. You have to convert this as well. This will give you 0.04 meters, and 1.9 divided by 100, that will also give you a 0.019 meter. So volume is basically multiplication of all the sides. That will give you a 0.074 multiplied by 0.04 multiplied by 0.019. The answer will be 0.00056 meter cube, or you can write it as, in a scientific term, 5.6 10 raised to power minus 5 meter cube. Okay, so 5.6 10 raised to power minus 5 meter cube. Question 3C. You have a mass in gram and you have to write down in the kg. So mass is 146 grams. To change grams into kg, you have to divide it by the 1000. Okay, so 146 divided by 1000 is equals to 0.146 kg. 0.146. Question 3D. The density of different metals are listed in the figure. In the table, use this information in the table to identify the type of the metal which the cuboid is made of. Okay, so you have to compare it from the previous data. So first of all, you have to find the density, because in the previous data we have found the mass and the volume. So density is equals to mass divided by volume. So mass was 0.146. So 0.146 was the mass, 0.146, and the volume was 5.6 10 raised to power minus 5. 5.6 10 raised to power minus 5. Dividing both of them, you get 2607 kg per meter cube. Okay, this is a density. So this is nearly equals to this one. So the material is aluminium. Okay, we have to identify the units of the velocity. Velocity is measured in meter per second. Explain how a scalar quantity is different from the vector quantity. Okay, so you can just simply write down the definition. Scalar only have magnitude, and vectors have magnitude and direction. Okay, so this is a basic difference between scalar and vector quantities. In the next question, they're asking you to show a vector diagram for two components of velocities. Determine the velocity of v2. Okay, if you see v1 is given, you have to find the v2. v1 is 6 meter per second. So it's v1 is starting from this point and ending at this point. So it is one complete box, 2, and the 3. So 3 big boxes are representing a 6 meter per second velocity. So 3 boxes are equals to 6 meter per second. So one box is 6 divided by 3, that is equals to 2 meter per second. So we have to find v2. So v2 is 1 box, 2, 3, 4, and 5. So v2 is equals to 5 boxes, and we know that 1 box is equals to 2, so 5 into 2 gives you 10 meter per second. So this is the value of v2. In the D part, calculate the magnitude of the resultant velocity of the component. Give your answer in two significant figure. Okay, so this is basically an example of perpendicular vectors. So whenever you have to find the sum of your resultant of perpendicular vectors, we have a relation that resultant velocity or resultant vector is equals to x component square plus y component square. Okay, you just have to take the squares and add them, and finally you have to get their square root. So it will give you x is this one, v2 is 10, and y is this one, it's 6. So that will give you, after calculation, 11.66 meter per second. And when you round it off for the 2 second figure, it will be, for 2 second figures, it will be 12 meter per second. Okay, this is the answer. In question 5a, we have to explain the difference between the speed and the velocity. So speed is scalar quantity, whereas velocity is vector quantity. Okay, this is the difference between them. It also depends on direction. Okay, it also depends on direction. Speed only depends on the magnitude. Okay, the next question, identify the scalar quantity. Time is a scalar quantity. Weight is vector. Weight is force basically. Acceleration is also vector. Distance is a scalar quantity. Okay, so it's time and distance. Question 5c, state another example of a vector quantity and scalar quantities. There are many examples of vector and scalar. If you want to write the vector can be force, it can be velocity, it can be acceleration, it can be displacement, etc. And for the scalar quantities, it can be mass, it can be speed, temperature. They are all scalar quantities. Okay, so you can write any one of them. 5d shows a vector diagram for the effect of two forces. Calculate the resultant. Okay, so there are two forces. Basically there are two vectors. One is f1 and second one is f2. So f1 is, this is in the y direction, and this one is in the x direction. So both are perpendicular to each other. We have to use the same relation that we have used before. The resultant vector will be, let's suppose it's r, it will be equals to x square plus y square. So x value is 196 plus y value is 238 square. So that will give you 308 Newton. So answer is 308, and you have to mention the units with it. Okay, next question is, a student has a pile of A4 paper for his computer printing. Shows the dimensions of the pile. We have dimensions, we have it's 25 and 30 centimeter. The pile contains 500 sheets of paper. Calculate the average thickness of one sheet of paper. Okay, so for 500 sheets, thickness is, this is the thickness of 500 sheets is equals to 5 centimeter. So if the thickness of 500 sheets is 5 centimeter, so thickness of one sheet will be 5 divided by 500. So 5 divided by 500 will give you 0.01, and units are given, that is centimeter. In the next part, show that the pile of paper has a volume of 3000 centimeter cube. Okay, you just have to multiply all the dimensions. Volume is equals to length into width into height. So that is 30 into 5 into 20. Okay, 30, 520, that will give you a 3000 centimeter cube. Okay. In part C, the student measure the total mass of the paper in the pile. State the name of the device used to measure the mass. Mass is measured by a balance. In next question 1D, The mass of the paper in the pile is 2400 grams. Calculate the density. So density is equals to mass divided by volume. Mass is 2400 and the volume is equals to 3000. That will give us 0.8 and the units are already given, that is gram per centimeter cube. A teacher investigates the reaction time of 5 students. 0.5 meter rule is held above the hand of the student before being allowed to fall. The arrangement is shown in the figure. As soon as the ruler falls, the student closes their hands, and we have a different data. We have a number of students A, B, C, D, and E, and the distance ruler falls. Okay, that is in centimeters. What we have to do using the result shown in the figure, calculate the average distance that the ruler drops. Okay, we have to find the average distance. So let's see what distances we have. For the first A student, the distance is at this point. Okay, if first of all we have to look at what one box is showing. One box is from this point, it's 2. There are how many small boxes? 1, 2, 3, 4. So 4 boxes are equals to what? 2. So 4 boxes equals to 2. So one box is equals to 2 divided by 4. That will give you 0.5. So if this is 8, this will be 8.5, this will be 9. Okay, and this is exactly 12. A is 9, B is 12. For C it is at 16, so C is 16. Sorry, this is D. D is 16, C is there. C is at this point, C is 8, and the D is 22. So these are the distances. So for the average distance, what we have to do, we have to add all of them and divide by number of distances. So it is A plus B plus C plus D plus E. A, B, C, D, and E. This is E, sorry. Okay, and divide by 5. So values are 9 plus 12 plus 8 plus 16 plus 22 divided by 5. The answer will be 13.4 centimeter. Okay, so 13.4 centimeter is answer. And the B part lists the student in order of their reaction time and the shortest reaction time of the top of the table. One has been done for you. Okay, we have to write down the reaction times. So reaction time is basically the first is C. C has a, we have to list them in order of reaction time, no? So the least reaction time is for the C because it fall the least distance. Okay, that is the 8. So looking at the graph, this will be C, then this will be A, B is already given, this will be D, and this will be E. 2C. In a similar investigation, a ruler dropped a distance of 11 centimeter and has an average speed of 16 centimeter per second. We have to find the time. What we have given is distance and speed. We have to find the time. So a relation that relates the distance, speed, and time is formula of speed. That is, speed is equals to distance divided by time. So time will be, this time will go there. It will equals to distance divided by speed. Distance is 11 centimeter and speed is 16 centimeter per second. Okay, we don't need to convert centimeters into meter because both the values are given in centimeters. They will cancel out with each other automatically. So 11 divided by 16 will give you 0.69 seconds. So 0.69 second is the answer. Units are given. In the next question, 3a, shows a large tank containing water. The tank leaks, drop of water fall from the tank. The drop hit the ground at a regular rate. what we have to find, there are different uh, data on the stopwatch given. We have to write down the time in seconds. First is there is 0 minutes, 0.1 seconds, so it is 0.1.24 seconds. This is also 1.14 second, and this is also 1.16 second. 0 minutes in this, and the first one as well. Okay, so we don't need to convert the minutes into seconds. In the second part, calculate the average time interval between the two drops of water hitting the ground. So we have to find the average time. We have three different readings for the interval between the two drops. Okay, we just need to find the average. The average value is average time. We have to add all of them and have to divide with number of values. So it's 1.16 divided by 3, because 3 were the total values. It will give us 1.18 second. So 1.18 second is the 1.18 second is the final answer. Don't need to write the second, it's given. 3b, another student measures the average time taken for a drop of water to fall from the tank to the ground. The time taken is 1.6. Calculate the average speed. We have our time in second, and what we have to find, we have to find average speed. So average speed is equals to total distance divided by total time. Time we have, that is time is 1.6. We have to look for the distance. So let's go back towards the question. Distance is given in the diagram, that is 12 meter. So distance is 12 meters. So dividing 12 by 1.6, that will give you 12 divided by 1.6. The answer will be 7.5 meter per second. Units are given. Okay. 4a, a student has a piece of metal that has an irregular shape. The weight of the metal is 3 Newton. You have to find the mass. Okay, so weight is equals to mass time g. G is 9.81, and so m will be weight divided by g. Weight is 3 and g is 9.81, that is constant. For the earth, that is equals to 0.306 kg. Okay, so it will be 0.3 for the 0.3 kg, we can write down. In the second part, B part of the fourth question, shows the piece of metal measuring cylinder and a beaker containing water. Describe how to determine the volume of the metal using the equipment. Okay, so for measuring the volume, what we need to we have to put this water into a measuring cylinder, and then we can find the volume of that liquid. And then what we have to do, we have to add this metal into the measuring cylinder. Then we will find the changed volume, and subtracting the changed volume from the initial volume of the liquid only, we get the volume of this metallic irregular shaped object. Okay, so this is the whole process. In the second question, explain why the procedure in B1 is not suitable for finding the volume of a piece of low density wood. Okay, low density wood objects will not sink, so it does not sink. That is the reason it is not suitable for it. The mass of another, next question, the mass of another piece of metal is 405 grams and the volume is given. You have to find the density, and you have to write down the units as well. So density is equals to mass divided by volume. Mass is given 405 grams and volume is 150 centimeter. So dividing both of them, you will get 2.7, and units are grams per centimeter cube. Question 5a. Two students are discussing mass and weight. Student 1 claims that a person weight will be different on Mars than on the Earth. Describe the difference between the mass and the weight and explain whether you agree with the student 1 or not. Okay, so basically you have to differentiate or define the mass and weight. So mass is a quantity of matter. Secondly, it is independent from gravity. So it does not matter the object is on the Earth or on the Mars, the mass will remain same. Okay, weight is pull off Earth or some other planet. So it depends on gravity of planet. So the weight will be different on different planets. Okay, but mass will remain same. Weight is equals to mass multiplied by g. G is gravitational field strength of that particular planet. Question 5b, identify the vector quantity. Displacement is a vector quantity and velocity is a vector quantity. Okay, distance and speed are scalar. 5c, the force acts at right angle to one another. 35 Newton force and other force is 42 Newton. So we have two forces and they are acting perpendicular. One is acting at the right and one is acting downward. We have to construct a scale diagram to show the effect of these two forces and label the resultant force x. And you have to use the scale that 10 Newton is equals to 1 centimeter. So if 10 Newton is equals to 1 centimeter, then 35 Newton force will be equals to 3.5 centimeter and 42 Newton force will be equals to 4.2 centimeter. So we have to construct a vector first for the 35 Newton force towards the right. So this is 3 point, let's assume this is with the scale you have to draw a 3 point. Let me draw it a bit higher. We have 3.5 toward the right side, 3.5 centimeter. You have to measure it with the scale, and 42 is downwards now, so it's 4.2 should be the length. You have to measure it with the scale, that is 4.2 centimeter. The resultant will be between these two forces. Okay, so it will be somewhere at this point. We can also use head to tail rule. In head to tail rule, what we have to do, we have to place the second vector. Let's assume this 4.2 is the second vector. Place the second vector, the tail of this second vector, on the head of the first, and draw a line in the same direction that will be going 4.2 centimeter. The resultant force will be from the tail of the first toward the head of the last. This will be the resultant, and we have to label this resultant with x. Okay, you can measure the length with the measuring scale. Okay, so the length of the scale will give you a magnitude. If you measure it should be x will be equals to 5.5 centimeters. So 5.5 centimeter is equals to, you have to multiply with 10, this will be 55 Newton. So magnitude will be 55 Newton, and you have to find the direction as well. So for magnitude we can apply formula to find this without measuring. If you want to find without measuring by the formula, you have to apply the formula that we have discussed in the previous questions, that x will be under root x vector was 3.5 square plus 4.2 square. Okay, so that will give you an answer 5.5 centimeter. By converting it into a Newton, that will be a 55 Newton, because there was a scale that 10 centimeter were equals to 1 Newton. And if you want to find the theta, that is direction, that will be tan inverse y vector divided by x vector. Y is 4.2, so tan inverse 4.2 divided by 3.5, the answer will be 50 degree. So the direction is 50 degree and the magnitude is 55 Newton. The next question. I wish to roast a chicken for a Sunday lunch. The chicken requires this much time, that is 1 hour and 20 minutes in the oven. The oven must be switched on at 10 minutes before and food is put in order to preheat and reach the correct temperature for the cooking. I wish the chicken to be ready at 4:30. At what time must I switch the oven on? Okay, so what are the condition? The oven need to be switched on. Switched on time was switch on time is 1 hour and 30 minutes. Okay, before. Okay, so basically this is the time, and what we have putting the chicken in cooking time. Switch on time is 1 hour and 30. Okay, the oven need this much time and 1 hour 20 minutes cooking time plus 10 minutes for the preheat. Okay, so 4:30 you need to serve minus 1:30, so you have to subtract from hours to hours and minutes to minutes. That will give you 3 p.m. Okay, so it's option D. Question 2. A particularly diligent student wants to measure the volume of some liquid for an experiment. She has two measuring cylinders available, a large 250 milliliter one and a small 50 milliliter one. The liquid will fit into either of the two measuring cylinders. As expected, the liquid form a meniscus where it touches the sides of the either measuring cylinder. Which cylinder should use to get the most accurate result and from where? Okay, so for the most accurate result, the large cylinders are less sensitive. Okay, so we can't choose A or B because they are less sensitive. Small cylinders are more sensitive. They will show a more change by a small variation in the liquid. So it should be from C and D, and we always measure the value from the bottom of the meniscus. So top is wrong, so it's only option D. Question 3. A geologist wants to measure the volume of a particular interested pebble she has found in a river. She uses the apparatus from the figure. What is the volume of that object? So if you see, the initially liquid volume was 5 and finally it is giving you a value, it's 17. So 17 minus 5 give you 12. So it's option, sorry, 17 minus 5 give you, it's 13. Minus 5 gives you a value 12. So the nearest value is 11 that we have. Okay, so sorry, in the first, this is not 5, this is 6, my mistake. Okay, let me do it again. There is 5 and this is 6 and this one is 15, this 16 and 17. So 17 minus 6 will give you 11. So it's option A. Okay, in the next question, a scientist is trying to determine the volume of 3 identical pieces of a new material, and she has placed in that. What we have to find, the first cylinder has the level water measuring cylinder and second cylinder shows the measuring cylinder piece of the. What we have to find, what is the volume of each piece of a new material. Okay, first of all, we will find the difference in the volume of the measuring cylinder. That will give us a volume of 3 pieces. So first volume is, it is at this point, that is 50, and with object its volume is at this point, that is 90. So 90 minus 50 is equals to volume of 3 new materials. Okay, and all have same volume, so identical volume, it's mean that was 90 minus 50 give us 40. 40 for 3, and for 1 it will be 40 divided by 3, that will give you 13.3 centimeter cube. 13.3 is option B. And the next question, question 5, which of the diagram below correctly shows two forces W and X with the resultant force? Okay, so you have to find the resultant force. We have to apply the head to tail rule or tip to tail rule. So if this is the first vector, second should be placed at its head. So it is not placed there, it's not the right option. This is entirely wrong. This is also not as per the head to tail rule. If you see the D option, if you consider the W is the first vector and the second vector is exactly placed at the head of the first, the okay, so, and the resultant will be from the tail of the first toward the head of the last. So this is the correct option, it's option D. Okay, so that's it for the measurement topic.